This is sample problem 5.5 in your textbook, but I've modified it. Instead of using inches, I've used the SI units. It says that the load L is being hosted by the pulley and the cable arrangement that is shown. Each cable is wrapped securely around its respective pulley so it does not slip. The two pulleys to which L is attached are fastened together to form a single rigid body. So the question is to calculate the velocity and acceleration of the load L and the corresponding angular velocity omega and angular acceleration alpha of the double pulley under the following conditions. So I'm going to be looking at condition A, where we are told that omega 1, which is equals to omega 1 dot, is 0. That is, the pulley is at rest. So we have pulley 1 is at rest and pulley 2 has a 2 radians per second, and the alpha is minus 3 radians per second. So A is fixed and B moves to B prime. That's the condition we're going to be looking at. The tangential displacement of the velocity and acceleration of a point on the rim of the pulley 1 or 2 is equal to corresponding vertical motion of point A or B. So you can see that we have the displacements, vectors that we have geometrical that we've shown. So this will be the velocities. As given here, you have ds0, that would be the displacement of point O, and then we have b to b prime, which is dsb, which would be the displacement of point B with A being fixed. So if you take the line AB and multiply that by d theta, that will give you ds0. So that is the displacement, and we can then find our velocity. Since we now have the displacement, we can now find our velocity by differentiating with respect to time the displacement, which is dsb over dt, which is the line AB, d theta dt. So that gives us AB omega, which is for A being fixed and B moving. We can then find our acceleration as well, the tangential component acceleration, which will be dv0 dt, and this is the line AB omega dot, which is AB alpha. Now we can look at the displacement of 0.0, and we already have both the displacement and we can find the velocity. So the displacement ds0 is a0 d theta through the angle d theta, and so we can easily differentiate this with respect to time to find our velocity, which will be the line AO omega ds0 dt, which is AO d theta dt, and that gives us the velocity of the point 0. And we can easily calculate then the acceleration by again differentiating the velocity with respect to time. And that will be dv0 dt, which is a0 bar omega dot, which is a0 bar. We know that omega dot is alpha, angular acceleration. Given the omega 1, which is the angular velocity for the first case, for the first pulley is 0, which means the acceleration is 0, and we know that the angular velocity for the second case, or the second pulley, is 2 radians per second, and the angular acceleration is negative 3 radians per second. These are all given in the question. So with Vd equals to R2 omega 2, because we know that Vd will be R2 omega 2, let's put it down here. So our Vd is actually 100 multiplied by 2, on where R2 is 100, of course. And then this gives us the velocity in millimeters per second. We can also find our acceleration. We know that it will be R2 alpha 2. So this gives us 100 multiplied by -3, which is the alpha. That gives us minus 300 millimeters per second square. Yeah, per second square. So we can then compute the velocity and an acceleration of the double pulley. Okay, so the velocity and acceleration of the double pulley, which is where the strings are attached. We can compute this as omega is equals to the velocity of B, VB, over the line AB. And that will give us VD over AB, which is equals to 200 divided by 300. And that will give us 2/3 radians per second. And this will be counterclockwise direction. We can then find our alpha, which is the tangential component, so ATA of B tangential over AB. That gives us AD over AB, which is equals to 300, or minus 300 over 300. So this gives us 1 radian per second, and this will be clockwise. Okay, so that was counterclockwise and this is clockwise. Now we find the motion of point O, the corresponding motion of point O, and the load B. So V0 is A0 multiplied by omega, which is equals to 100 multiplied by 2 over 3. That will give us 66.67 millimeters per second. And so we can also compute the acceleration of point 0 to be A0 alpha, which is equals to 100 multiplied by minus 1, which is minus 100 millimeters per second square.